In this video, we'll be going through section B of the 2025 specimen paper for H2 Math revised syllabus 9758. Question 5 is a permutation and combination question. So let's take a look at it. So now this question is about 6 couples, and each couple consists of a husband and a wife. The 12 people visit a theater and sit in a row of 12 seats. So in part A, you're asked, in how many different ways can the 12 people sit so that each husband and wife in a couple sit next to each other? So in order for the couples to sit with each other, so there are 12 seats here. Okay, so I can just group 2 seats, okay, as a set. Okay, 2 seats as a set. Maybe a circle is a seat. So 2 seats as a set, right? And each set of seats is to be set by the husband and his wife. Alright? So I can look at it as the number of ways, okay, is equals to 6 factorial because there are 6 sets of seats. Then I need to times 2, times 2, times 2, times 2, times 2, times 2, or times 2 to the power of 6. Because for each set of seats, the husband and wife can swap seat. You can have husband and wife, or wife and husband seated this way, right? And this is true for all the other set of seats. So the total number of ways is equals to 6 factorial multiplied by 2 to the power of 6. Okay, and you have the answer of 46,080. Moving on to part B, in how many ways can the 12 people sit so that the 6 wives all sit next to each other? So if the 6 wives all sit next to each other, we will let these 6 wives, okay, be in a group, right? And exactly 2 of the wives sits next to their husband. So if the 6 wives sits next to each other and exactly 2 of them sit next to their husband, what does this mean? Well, it means that the 2 wives who are at the end of these groups are sitting right beside their husband. So if this is wife A, this is husband A. If this is wife B, this is husband B. So in other words, right, these 2 husbands has no choice in their seat. There's only one way of selecting their seats, right? Okay, because once you have this wife A here, husband A must sit here. If you have wife B here, husband B must sit here. Because we need exactly 2 of the wives to sit next to their husband, and for all the 6 wives to sit next to each other and the husbands sit next to 2 of the wives, it means that the wives who are sitting at the end, okay, are sitting right beside their husbands. Okay, so to find the number of ways, the first thing we'll do is we'll take 6 factorial because there are these 6 wives here and they're all sitting together and they can swap their position. So once I have these 6 wives being seated, I have these 2 husbands. Okay, so out of the 6 husbands, 2 of them are already seated because they have to sit beside the 2 wives who are at the end. So if this is wife A, this will be husband A. If this is wife B, this will be husband B. So there's no way of choosing where husband A and husband B sits. So 2 of them have already been seated and we have 4 more. So for the 4 other, you could have none of them here and 4 of them here, right? Or you can have 1 of them here and 3 of them here. You can also have 2 of them here and another 2 of them here. 3 of them here and 1 of them here. And none of them here and none of them at this side, and all of them are at this side. So there are actually 1, 2, 3, 4, 5 combinations. Okay? And in the 5 combinations, all the 4 husbands are allowed to sit anywhere they like among the 4 seats. So you have 4 factorial. So the number of ways in part B will be equals to 6 factorial times 5 times 4 factorial, which gives us 86,400. Alright, moving on to part C. The group decides to form a committee to arrange future outings. The committee will consist of 3 of the 12 people. Okay, so how many ways can the committee be formed without restriction? So basically, we want to choose 3 out of 12 people. So the number of ways will be 12 choose 3. And this is equals to 220. Next, moving on to part D. In how many ways can the committee be formed such that at least one of the wives will be on the committee, but no husband and wife couple will be included? Okay, so we know that there is at least one wife. So we have cases of one wife, 2 husband. Case 2, because we have at least one, right? So you can have 2 wives. And then because they are a committee of 3, so there is 1 husband. Then case 3, I have 3 wives. Okay? So now I know there are total 6 wives and 6 husbands, right? So for case 1, the number of ways will be, I want to choose 1 wife out of this 6, so 6 choose 1. Then because once this wife is chosen, her husband cannot be inside the committee. So there are 5 husbands to choose from, and I need to choose 2 husbands out of this 5 to be in the committee. Okay, so that is why I have 5 choose 2 here. So 6 times 1 times 5 choose 2, I get 60. Next, I have 2 wives and 1 husband. So the number of ways will be equals to, I need to choose 2 wives out of 6, so it's 6 choose 2. Then once these 2 wives are chosen, their husbands cannot be in the committee, so I only have 4 husbands left to choose from, and I need to choose 1 husband from these 4, so it's 4 choose 1. So for case 2, the number of ways is 6 choose 2 times 4 choose 1, okay, which gives us 60. For case 3, we have 3 wives and 0 husbands, right? So number of ways is basically just 6 choose 3, okay, because we want to choose 3 wives out of the 6, and 6 choose 3 will give us 20. So total number of ways will be equals to 60 plus 60 plus 20, which gives us a total of 140. Okay, so for part D, the answer is 140. Next, let's move on to question 6. So question 6 is a linear regression question. Giant pumpkins are often irregular in shape. Growers of giant pumpkin measure the size of a pumpkin using the over-the-top length. Pumpkin growers keep records so that they can estimate the mass of the giant pumpkins while they are growing. The over-the-top lengths, d meters, and the mass, m kg, of a random sample of 7 pumpkins are as follows. So in 6A part 1, you are asked to draw a scatter diagram of the data. So basically, this one, just use your TI-84 graphic calculator and plot this scatter plot. Okay, so you should get something that looks something like this. Okay, something like this. So this is the scatter plot. So you need to label them. So you need to label here as M. Okay, kg. I should put in the kg. Okay, so you should put in kg here. And also D in meters. Okay, I'll update it in the file that you can download, link in description below, of this entire document for the work solution of the specimen paper. Okay, then you need to put in the lowest value of M and the highest value of M, the lowest value of D and the highest value of D. Okay, label them. Okay, and then just plot out the points where they should roughly be. All right, so you should get a plot that looks something like this, okay, with your GC. Okay, Now that we have drawn this scatter plot, next you're asked to explain how you know from the diagram that the relationship between M and D should not be modeled by a linear equation involving M and D. So you need to use your diagram to explain. If it's a linear equation, you should have a straight line, right? So what you will write is this: the relationship between M and D is nonlinear as the points do not form a straight line. So if you look at this, it's actually a curve, right? Okay, part B. Which of the two equations M equals to ED squared plus F and M equals to GD cubed plus H, okay, where E, F, G, and H are constants, is the better model for the relationship between M and D? So what you need to do now is to do a linear regression between M and D squared and M and D cubed and see which one has a R value closer to 1. Okay, because this is a positive relationship where M increases, D also increases, so your R value will definitely be positive. So the nearer the R value is to 1 for the model, the better the correlation. Okay, so this is basically a GC work. So make sure you're familiar with how to use the GC for linear regression, okay, and how to find your R or R squared value. Okay, so this is how you present your answer. So do a linear regression of M versus D squared and put down the E values as well as the F value as well as the R value. So for this case, you have R equals to 0.98889. Then do a linear regression of M versus D cubed. And these are the values of G and H. And your R value is 0.99. So the R value for this model, this cubic model, M equals to GD cubed plus H, is closer to 1 than this model here, of M against D squared. So in other words, right, this cubic model or M equals to GD cubed plus H is a better model as R is closer to 1 for this model. Then you need to write out the relationship, okay, by just putting in the values of G and H into this equation here. Okay, so this chapter here for your linear your correlation and regression and linear regression, right, is very easy to score. So just make sure that you're familiar with how to use your calculator, okay, to obtain the E and F, the constant values, as well as your R values. All right. Now moving on to part C, part 1. So you're asked to use the equation you have chosen in part B to estimate the mass of the pumpkin with over the top length of 6 meters. So in other words, when D is 6, what is M? So we are going to sub in, okay, because in part B, we say that the better model is this one here, right? M equals to GD cubed plus H. So we are going to sub in D equals to 6 meters into this equation here, okay? This equation here. So we got M equals to 127 kg when rounded off to 3 significant figure. Do the same for the next part, okay? When D is 12 meter, find what is M. So use the same equation again, which is this one here. Okay, sub in D equals to 12 meter and you'll get M equals to 992 kg. All right. So now that we have done with C part 1, we are asked to explain which of your estimates is more reliable. Whenever they ask which estimate is more reliable, you always look at either the R value or is it interpolation or an extrapolation. So we are finding the M value for D equals to 6 and D equals to 12. So if you look at D equals to 6, it is an interpolation because our D value range from 2.31 to 9.17. So 6 meters is within the data range of D. So A would be reliable. But for D equals to 12 meters, okay, it is an extrapolation because this 12 meters value is out of this range here. So therefore, A is more reliable because it is an interpolation. So you're right that A is a better estimate than B because A is an interpolation while B is an extrapolation. Let's do question 7. So question 7 is a binomial distribution question. So crunches are sweets that are sold in packets of 8. Each packet is made up of randomly chosen colored sweets. On average, 15% of the crunches are yellow. So in A, you're asked to find the probability that a randomly chosen packet of crunches contain no more than one yellow sweet. So we will define a binomial distribution X. So we'll say let X be the number of yellow crunches out of 8, right? So X takes a binomial distribution of what's the probability of one cruncher being yellow? Well, it is 15%, so it's 0.15. Okay, so X takes binomial distribution with n equals to 8 and p equals to 0.15. So we are asked to find what is the probability that a randomly chosen packet of crunches contain no more than one yellow sweet. So you are asked to find p of x lesser than or equals to 1. So we will use our graphic calculator TI-84. We will use Binomial's CDF. Okay, so put that into the calculator and you will get a value of 0.657 when rounded off to 3 significant figure. Alright, moving on to part B. Kev buys 70 randomly chosen packets of crunches. So remember, each packet of crunches contains 8 crunches. Okay, find the probability that at least 50 of these packets contain no more than one sweet. So we have 50 packets of crunches, right? So this is 50 packets of crunches, and each packet contains 1, 2, 3, 4, 5, 6, 7, 8, right? Okay, and we want to find the probability that at least 50 means more than or equals to 50, okay, contain no more than one yellow sweet. Okay, so what we need to do is we need to define a new binomial distribution. So we will let y be the number of packets of crunches out of 70 that contain no more than one yellow crunches. Okay, so now the distribution of y takes binomial with n equals to 70 and the p equals to 0.657, which is what we have found in part A. So now we are interested in p of y greater than or equals to 50. And remember, your calculator is unable to do more than or equals to. It can only do less than or equals to for binomial distribution. So you'll need to change it to p1 minus p of y lesser than or equals to 49. Then type it into your GC. You will get a probability of 0.190 when rounded off to 3 significant figure. Okay, next. On average, the proportion of crunches that are red is p. It is known that the modal number of red sweets in a packet is 3. Use this information to find exactly the range of values that p can take. Okay, so now we are going to look at one packet again, right? But now we are not interested in yellow crunches. We are interested in red crunches. So let's redefine the binomial distribution. We will let R be the number of red crunches out of 8, right? Because one packet has 8 crunches. So R takes binomial distribution of 8, p, and we need to find what is p, right? And what else are we given? They tell us that the modal number, that means mode, right? So the mode is equals to 3. So we know that mode occurs at r equals to 3. So if the mode occurs at r equals to 3, what does it mean? Well, it means that p of r equals to 2 is lesser than p of r equals to 3, and P of R equals to 3 is greater than P of R equals to 4. Okay, so because the binomial distribution looks something like that. Okay, maybe this is like 0, 1, 2, 3, 4, something like that. So the mode is 2. So if the mode is 2, that means the probability of the values, one less and one more than it will be lesser than it. Okay, so now that we have talked about this, we need to find P, right? Okay, so they want to find exactly the range of values of P. So in other words, you're not supposed to use your GC to solve for P. So how do we do that? Well, you can go to your formula booklet, and under the page here on distribution, we need to make use of this formula here to find the probability. So we know that, okay, we have R takes binomial distribution 8, P, and we know that n equals P of R equals to 3 is the mode, right? And that means, so what we'll do is we'll sub in x equals to 3 here, n equals to 8, and P as P. We'll find P of R equals to 3, and then do the same for R equals to 2 as well as 4. Okay, so making use of that formula from the formula booklet, okay, we are going to write this. So this is the same as 8 choose 3, okay, 8 choose 2, then P square 1 minus P to the power of 6. And then P of R equals to 3 is P 8 choose 3, P cube 1 minus P to the power of 5. Okay? And do the same. This is P of R equals to 3. So basically just copy this. 8 choose 3, P cube 1 minus P to the power of 5 greater than 8 C4 P4 1 minus P to the power of 4. So now let's first solve this inequality. Okay, so I know that 8 choose 2 is essentially 28. Okay, then I have 8 choose 3 is 56, right? Okay, then I have P square 1 minus P to the power of 6. Okay, what I'm going to do now is, for this inequality here, I'm going to divide both sides by 28. P square 1 minus P to the power of 5. And I can do that because P is a probability. 1 minus P is also a probability. So P and 1 minus P are all more than 0. So we can divide things, okay, by a number if we know that it's going to be greater than 0. Okay, reason is because if we do not know, so it's unlike your normal inequalities, we say you cannot divide, right? Because usually x can be negative, it can be positive. If x is negative, we need to swap this sign of the inequality. If x is positive, we do not need. But we do not know, right, for those type of inequality. But this is a probability question. We know for sure that P will be positive. We know that 1 minus P is also a probability. It's the probability that the cruncher is not red or a cruncher is not red. So it will also be positive. It's in between 0 and 1, right? So because we know that they are going to be more than 0, they are not going to be negative, or 28P squared 1 minus P to the power of 5 is going to be positive. So therefore, we can divide both sides by a number that we know for sure is more than 0. Okay, so simplifying this, I have 1 minus P is lesser than 2P. Okay, so solving for this portion here, I have P is greater than 1/3. Okay, do the same for this portion here. Okay, I will have again 56P cubed 1 minus P to the power of 5 is greater than, so 8 choose 4 is 70. So 70P to the power of 4, 1 minus P to the power of 4. Okay, so now I'm going to again divide both sides by 14 P p cubed 1 minus p to the power 4, right? So if I divide that, so this one, 56 divided by 14 is 4. P cubed over p cubed, no more p cubed is 1. Then I have 1 minus p here. And it is going to be greater than 5p. And solving for this, I have p is lesser than 4 over 9. And remember, in order for r equals to 3 to be the mode, these two inequality must be satisfied. So it's an and. So we must find the intersection of these two inequalities to find the range of values of p, right? So I know that p is greater than 1/3. So this is 1/3 and it is greater than 1/3. P is lesser than 4 over 9. So taking intersection, we know that P is in between 1/3 and 4 over 9. So range of values P can take will be equals to from 1/3, 4 over 9. Okay. Alright, now let's move on to question 8. So question 8, a bag contains 3 blue discs, 2 red discs, 1 yellow disc. Lee chooses 3 discs at random from the bag without replacement. Show that the probability that Lee chooses 1 blue disc, 1 red disc, and 1 yellow disc is 36y over this. Okay, so I know that total number of this is 3 plus 2 plus y, which is 5 plus y, right? Is the total number of discs. Okay. So to find A, the required probability is equals to, what's the probability of choosing a blue disc is 3 over 5 plus y, right? And the next disc being a red one is 2 over 4 plus y. Okay, why is it 4 plus y and no longer 5 plus y? Because once you have chosen one disc, there is one less disc. So the number of discs now becomes 4 plus 1 y. Now you have y yellow disc left, and the probability of choosing a yellow disc will be y over 3 plus y. Okay, because it's without replacement, so the total number of this decreases by 1 again. So now that we have done this, the next thing we need to remember that is I can have blue, red, yellow. I can have blue, yellow, red, and so on. So how many ways are there to arrange blue, red, and yellow? Well, there is 3 factorial ways. So I need to account for these 3 factorial different ways, right? So therefore, I need to multiply this by 3 factorial. So simplifying, this 3 factorial is 6. 6 times 2 is 12. 12 times 3 is 36. So I end up having 36y over y plus 5, y plus 4, y plus 3. So I've shown what I'm asked for in part A. Now moving on to the next part. Lee's discs are replaced in the bag. Okay, that means now it goes back to 3 blue, 2 red, and y yellow discs. Okay, so they put back all the discs that Lee has taken out. Next, Davina chooses 3 discs at random from the bag without replacement. The random variable S is the sum of the number of blue discs chosen and twice the number of red discs chosen. Okay, and we are asked to find an expression in terms of y for P s equals to 3. Okay, so we know that when so if I were to let R be number of red discs, okay, B be number of blue discs, and Y, uppercase Y, be number of yellow discs, Davina choose, okay, then I know that S is going to be equals to B plus 2R, right? Alright, so now we are looking at P of S equals to 3. Okay, we are asked to find what is P of S equals to 3. So what are the possibilities of P of S equals to 3? Well, we could have P of S equals to 3 when there are 3 B's, right? Okay, so if there are 3 blue discs that are being chosen by Davina, then S is equals to 3. Okay, and because only 3 discs are chosen, R is 0, Y is 0. Now, can we have 2 blue and either 1 red or 1 yellow to get S equals to 3? No, not possible, right? Because each red is twice. So S is equals to 2R, right? So if I have 1 R, I'll have 2, I'll add 2 here, right? Then I'll end up having S equals to 4. Similarly, if I have 2 and 1 here and 0 R here, I'll have S equals to 2. So I know that in order to obtain S equals to 3, B cannot be equals to 2. Now let me try B equals to 1. So if B is equals to 1, how do I get 3? Well, R is equals to 1. So when R is 1, because S is equals to B plus 2R, this will be equals to 3. So in order for P of S to be equals to 3, you either have 3 blue discs being selected, or 1 blue, 1 red, and 1 yellow. Okay, because there are 3 discs, right? So 1 blue, 1 red, the other one must be yellow. Okay, so now let's find the probability of P of S equals to 3. So if you want to have 3 blue, it will be the first one is blue, second one is blue, and third one is blue. And there is only one way of obtaining blue, blue, blue. Okay, next I want 1 blue and 1 red and 1 yellow. So this is equals to what we have found in 8a, right? Which is 36y, y plus 5, y plus 4, y plus 3. Okay, so if we were to write it together, it is 6 plus 36y, okay, y plus 5, y plus 4, y plus 3. Okay, so this is the answer for part B, where we are asked to find an expression for S equals to 3. Now moving on to part C, we are given that when P of S is equals to 3, the probability is 7 over 20. So we are asked to calculate the value of Y. So we are going to equate this expression here, 6 plus 36y over y plus 5, y plus 4, y plus 3, to be equals to 7 over 20. Okay, so let's do that first. Okay, and because the question didn't ask for exact value or without using the calculator, and typically for statistic questions, right, typically they won't ask for exact values. One exception would be this one here, where they want the exact value, so we do not use the calculator to find. Okay, but for this question here, okay, we can use the graphic calculator to find it. So just type in solve for the unknown. So by GC, okay, you'll find that Y is equals to 1. In other words, I have 1 yellow disc in the bag. All right, so now I know that this bag has 3 blue, 2 red, and 1 yellow. In other words, right, the total number will be 6, right? So I have 6 this, right? So now what does the question ask us? So they say they want us to find, so we have already calculated the value of Y. So next what we need to find is to find the probability distribution of S. So we recall that from the previous part, S is equals to B plus 2R, right? So let's take a look at what are the possibilities that we can have for B plus 2R. So let's start off with B, R, and Y. And then from there, we calculate S. Okay, recall that B is the number of blue discs. We have defined it in part B. R is the number of red discs. And Y is the number of yellow discs that Davina chose. Okay, so we have already defined that in part B, so we do not need to do it anymore. Okay, and we also know that S is equals to B plus 2R. So we need to find the probabilities, right? Okay. Okay, so let's have a system of doing this so that we won't miss things out. So what I'll usually do is maybe I'll start off with 3 blue. Then if I have 3 blue, I will have no red and no yellows, right? So S is 3. Okay, and I found the probability already. It is basically 3 over 6 times 2 over 5 times 1 over 4, right? So let me write it 3 over 6 times 1 over 5 times 1 over 4. Okay, and 3 over 6 times 2 over 5 times 1 over 4, because there are 3 blue, so after the first this is taken, you have 2 more, then 1 left. Okay, so this will give me 6 over 6 times 5 times 4, so it's 1 over 20, because if I can cancel, 3 times 2 is 6, so that I can cancel, so it's 1 over 20. Next, there are no other possibilities for having 3 blue, okay, because I'm only going to select 3 this. So now let's have 2 blue. So if I have 2 blue, I can have 1 red and 0 Y, and this will give me an S of 4. Okay, and what is the probability? So well, it will be it will be 3 over 6 times 2 over 5. Then because there are 2 red, right, it's 2 over 4. Then I'm going to select 3 discs, so 3 factorial, but 2 of them are of the same color, so divide by 2 factorial, and this will give me a value of 3 over 20. Okay, wait, sorry, 3 over 10. 3 over 10. So again, I can cancel this. Then this one, 3 factorial over 2 factorial is 3. This one is 2. Yes, so it's 3 over 10. Okay, next, if I have 2 blue, I can have 0 red and 1 yellow. And the S will be equals to 2, right? Okay. So the probability would be 3 over 6 times 2 over 5. So select blue, then there's only 2 blue left and 5 this left, so the probability having the next one being blue is 2 over 5. Then next, times 1 over 5, because there's only 1 yellow, sorry, times 1 over 4. Okay, so this will give us a probability of 1 over 20. Okay, is it? Wait. Yeah, 1 over 20. Okay, now I have no more options with having 2 blues. Okay, so now I move on to having 1 blue. If I have 1 blue, I can have 2 red and 0 yellow, and so this will give me a score of 5, right? Okay, so and that would give me a probability of 3 over 6 times 2/5 times 1/4 times there are 3 discs and 2 of them are the same, so times 3 factorial over 2 factorial, and this one will give me 3 over 20. Next, if I want 1 blue again, I can have 0 red, but I cannot have 2 yellow because there's only 1 yellow, so I cannot have 0 red, so I must have at least 1 red because I will at most have 1 yellow, right? So 1 blue, 1 red, 1 yellow, and the total score is 3. And from here, this portion here, I know that the probability is never mind, it doesn't matter. Okay. So from here, I know that the probability is 3 over 6 times 2 over 5 times 1 over 4, and because there are 3 different discs of different colors, so it's times 3 factorial. So this will give me a probability of 3 over 10. Okay, now that I've looked at 1 blue, let's go on to 0 blue. So if I have 0 blue, I can have 2 red and 1 yellow. Okay, and because each R will give me a score of 2, so this is 4. So the probability will be 2 over 6 times 1 over 5 times 1 over 4, and because there are 3 discs and 2 of them are red, so it's 3 factorial over 2 factorial, which will give me a probability. So this is 1/3, this equals to 3, right? So you cancel off, so the probability is 1 over 20. So now that we have found this, we can set up the probability distribution of S. So when S is 0, the probability is 1 over 20. Only this one, right? When S is 1, okay, there is no probability that S is 0. We should be looking at this value here. Okay, so the smallest S value is 2. So when S is 2, the probability is 1 over 20. Right, okay, 3 over 6. Oh, I missed out times 3 factorial. Sorry, it should be 3 over 20. When S is 3, it is this and this, right? So it's 1 over 20 plus 3 over 10. So total is 7 over 20. When S is 4, we have this, right? So it's 3 over 10 plus 1 over 20, which is again 7 over 20. When S is 5, it is here, the probability is 3 over 20. So this will give us the probability distribution of S. Now let's go through question 9. Question 9 is a normal distribution question. So in this question, you should state the parameters of any normal distribution you use. In other words, you need to define the normal distribution, like let X be whatever, right? The mass of whatever, the length of what, the radius of whatever. Okay, so this is what it means in bold. So let's take a look at the question. A type of metal bolt is manufactured with a nominal radius of 0.8 cm. In fact, the radii of the bolts measured in cm have a distribution n, which takes a normal distribution of 0.8, 0.01 squared. So you're asked to find the percentage of bulbs that have a radius between 0.79 and 0.82 cm. So to do this question, the first thing you need to do is to define what takes the normal distribution 0.8, 0.01 squared. So this is question 9. So I will first let B be the radius of a metal bolt in cm. So B takes normal distribution 0.8, 0.01 square. All right. Okay. Okay. So this is my distribution. So we have already defined the normal distribution here. And the next thing you need to do is to find the percentage of bulbs that have a radius between 0.79 cm and 0.82 cm. So we first find what is the probability of bulbs that have a radius between 0.79 cm and 0.82 cm. So basically just type it into your GC and get the probability, which is 0.819. So because they asked for probability, so you'll not leave your answer as 0.819. Instead, you'll write it as 81.9%. Okay, so the answer is 81.9%. All right, moving on to part B. So next we have metal washers. They are manufactured to fit on the bolt. So the washers are the things that are outside, okay, and they need to fit on the bolts. So the inside radius of the bolts measured in cm has a distribution of 0.81, okay, 0.012. So this one is the mean, and this is sigma square, or standard deviation square, or your variance. Okay, and you're asked to write down the distribution of the inside circumference of washers in cm and find the circumference that is exceeded by 5% of the washers. So what we'll do is, again, we need to define the inside circumference of the washer. So we know that the radius of the washer is taken by this. So how do you find circumference? Circumference is basically 2 times pi times r, right? So what we'll do, we'll let C be the inside circumference of a metal washer in cm. And we know that C is equals to 2 pi r. And this r is basically, and this r is basically takes a normal distribution of 0.81, 0.012 square. So to find the, maybe let me not call it r. So if X is the radius, okay, of the washer, and X takes normal distribution of 0.81, 0.012 square, then circumference, which is 2 pi x, will be such that the mean, or the expected value of C, is equals to the expected value of 2 pi x, which is equals to 2 pi the expected value of x. So how I got 2 pi times 0.81 is I take 2 times pi times the mean or the expected value of x, which is the radius of the washer. Okay, now I need the variance, right? So the variance of C is equals to the variance of 2 pi x, and 2 pi is a constant, so if I want to bring it out, it will be equals to 2 pi squared variance x, and variance x is 0.012 square. So therefore, this is how I got, and if I want to write it, I can write this as 2 pi times 0.012 square, okay, which is the same as 0.024 pi square. Okay, so this is the variance of the circumference, and because the question asks for the distribution for the circumference of the metal washer, this is the answer here. Next, we are asked to write down the distribution of the inside circumference of washer, okay, which we have done, and then find the circumference that is exceeded by 5% of the washer. So in other words, right, they are asking us to find the value of C, okay, the value of X, okay, that is where the probability is equal to 0.05. Okay, so use your inverse norm, okay, with this as your mean and 0.024 pi as your standard deviation, and you'll get x equals to 5.21. So the required circumference will be 5.21 cm. Okay, next, going on to the next part. A bolt and the washer are a good fit if the inside radius of the washer is greater than the radius of the bolt, and the inside radius of the washer is not more than 0.04 cm greater than the radius of the bolt. So let's write this out in math, okay? So if I let the inside radius of the washer be R and the radius of the metal bolt be B, so this is what I have, right? It is good if the inside radius of the washer, which I define it as R, is greater than the radius of the bolt. Radius of bolt, we define it as B, right? And the inside radius of the washer, which is R, is not more than 0.04 cm greater than the radius of bolt. That means R minus B is lesser than 0.04. So if you look at these, it is basically R is greater than B, or R minus B is greater than 0, right? So in other words, we are looking for the probability of R minus B in between 0 and 0.04, right? So because we want to find R minus B, the probability of R minus B in between 0 and 0.04, the first thing we need to do is to first define the distribution for R minus B. Okay, so to find the distribution, we need to find what is the expected value of R minus B, right? And it's equals to ER minus EB. And the expected value of the inside radius of the washer is simply 0.81. It is given in the question here. Oops, sorry, 0.81 here. And the expected value of the radius of the metal bolt is 0.8, which is given here. And that is how I got 0.01 here. Next, to find the variance of R minus V, it will be equals to variance of R plus variance of B. Remember, you always add variance, never minus them. Okay, so I take 0.01 square plus 0.012 square. And I'm going to look for the probability of R minus B in between 0 and 0.04. So basically just use your normal distribution. Lower limit is 0, upper limit is 0.04 with a mean of 0.01 and a standard deviation of square root of this whole thing here. Okay, and you'll get a probability of 0.712 when rounded off to 3 sig feet. Now moving on to part D, the outside radii of washers measured in cm have the distribution of mu and sigma square. So now mu and sigma square are unknown. So when mu and sigma square are unknown, very likely we need to standardize, okay, change it to Z. It is known that 15% of the washer have an outer radius greater than 1.25 and 25% of them have an outer radius of less than 1.15. So let's try to write this out mathematically. So I will first let y be the outer radius of the washer in cm. Okay, and we know that y takes this distribution. Okay, then we know that 15% of the washer, so that means I have a probability of 0.15 where y is greater than 1.25. And I also have a probability of 0.25 when the outer radius is less than 1.15. Okay, so now because mu and sigma, okay, wherever your mu or n, your sigma is unknown for your normal distribution, you will need to standardize it. That means change it to z, right? So how do we do that? Well, we will change it to z, and we know that z takes a normal distribution of 0 and 1. So now we can make use of inverse norm or normal distribution. Okay, so let's first change this to z. So it will be equals to 1.25 minus mu over sigma. Okay, it is equals to 0.15. And because we know the probability, we want to find this value here, it will be inverse norm. So if you do an inverse norm, you'll get you'll get a value of 1.036. Okay. Okay, recall that for this inverse norm, because we are using z already, so your mu is 0, your standard deviation is 1. Okay, so you get this value here. So you'll form one equation here. Similarly, we have probability of y lesser than 1.15 is 0.25. So we need to standardize this, change it to z using the formula, okay, which is basically 1.15 minus mean over sigma. Okay, and then because we are given probability, we want to find this value here, so we'll do an inverse norm. So doing an inverse norm with a mean of 1 and a standard deviation, with a mean of 0 and a standard deviation of 1, we get negative 0.674489. Okay, another thing to note, this is the left tail, this is the right tail. So smaller than is the left, then greater than is the right when you're doing an inverse norm. So once you've done that, you found out that this is equals to negative 0.674489. Basically, now you have two equations. To solve for mu and sigma, just type it into your graphic calculator. Use Poly simultaneous, okay, to solve for it, or alternatively, you can use your scientific calculator if it can solve simultaneous equations. So by GC, you'll get a mu value of 1.19 and a sigma value of 0.0584. Okay, and that's how you do D. So you notice that, right, for most of the normal distribution questions, right, they always involve forming a new distribution. Okay, so you need to be able to find what is the expected value, what is the new variance of the distributions. Then you use inverse norm if you know the probability and you want to know what is this value here. So given probability, you want to find what is this value here, you use inverse norm. If you know this value here, the lower and upper limits, and you want to find probability, then you use norm CDF. Another thing to remember for normal distribution is if your mu and or your sigma is unknown, then you need to standardize. Okay, change it to Z. Now let's move on to question 10. So this is question 10, a hypothesis testing question cum sampling question. Okay, so let's take a look at this question here. Yeah, given that the average time required for the manufacture of a certain type of electronic control panel is 17 hours, an alternative manufacturing process is trial, and the time taken T hours for the manufacture of each of the 50 randomly chosen control panels using the alternative process is recorded. The results are summarized as follows. So you know these are the values. Okay, so in part, so the production manager wished to test whether the average time taken for the manufacture of a control panel is different using the alternative process. So they are only asking whether it's different. It can be more than, it can be less than. So basically we are testing whether mu is not equals to 17 hours in the alternative hypothesis, or your H1. Okay, so because we are looking at mu, so our H1 involves testing mu not equals to 17. So Therefore, it is a two-tailed test. All right. Okay, so it's a two-tailed test because he is testing whether the average time taken for the manufacturer of a control panel is different using the alternative process. So it can be greater, it can be lesser than. So it is a two-tailed test. You only use a one-tailed test if it's more than or less than. Okay. Moving on to part B, explain why the production manager is able to carry out hypothesis testing without knowing anything about the distribution of times taken to manufacture the control panels. So whenever they ask why you can still do the hypothesis testing, or why do you, without knowing the distribution, it is always central limit theorem. So when can you use central limit theorem? When you are finding the mean of something, when you have looking at the mean of something, so it must be mean or total of something, and it must be n greater than 30. Okay, so this is what you write. Since the sample size is 50, here is 50, right? Which is more than 30. Okay, the average time could be approximate to a normal distribution by central limit theorem. So memorize this, come up very often. Okay. Next, part C, part 1, find the unbiased estimate of the population mean and variance. This one is basically use your table, right? Sorry, use the formula from MF27. So, where is it found? Here, okay? So, your S square, your unbiased estimate of the population variance S square, you use this formula. And if you take a look at what is given, if you take a look at what is given, you have sum of t and sum of t square. So you will be using this one here. Okay, so now let's find the unbiased estimate of mu. So to find the unbiased estimate of mu is basically sum of t over n. Alright, so we'll take sum of t over n and it will give us 16.714. Next, to find unbiased estimate of population variance, this one is from your MF27. We'll use this formula here. So you just sub in the values, and is 49. Sum of t square is 14067.17, and sum of t is 835.7. Sub them in, type it into the calculator, you'll get 2.03 when rounded off to 3 significant figures. Next, let's move on to the next part. Okay, so we are asked to carry out the test at the 10% significance level for the production manager. Define any terms you use, okay? So basically, your normal hypothesis testing, because everything is known, there's no unknown, so it's just use your p test, your p value, okay, for the hypothesis testing. So this is what you do, okay? Remember to memorize the steps for hypothesis testing. It's very easy to score, okay? So first, you'll talk about what is H0, what is H1. So this is a two-tailed test. So H0, your mu is 17. And your alternative hypothesis, H1 is mu is not equals to 17. And because they say you define all terms, right? So you can also write this now, hypothesis, comma, H0. Then this one is alternative hypothesis, comma, H1. Okay, and you define mu here, right? So where mu is, what is mu? Okay, look at the question, just need to copy, right? So mu is the average time required for the manufacture of a certain type of electronic control panel. So copy this. This is mu, okay? So where mu is, okay, I just want you to copy from there. All right, this portion here. Average time required for the manufacture of a certain type of control panel. Okay, now coming here, since n, what is n? N is sample size. Since n equals to 50 is large, we need to do a central limit theorem, right? The previous part already tell us you need to talk about central limit theorem. Okay, T bar takes this normal distribution approximately by central limit theorem. Okay, next we are doing this hypothesis test at 10% significance level. So let's talk about it. Then now we'll type everything into your GC to find what is the p-value, and it is 0.155. 0.155 is 15.5%, right? Okay, since p-value of 0.155 is greater than 0.1, which is because we are doing 10% level of significance, so it means that we do not reject H0 and conclude that there is insufficient evidence that the average time of the alternative process is different. Okay, just memorize how you define this. All right, now moving on to the next part. The finance manager wishes to test whether the average time for the manufacture of a control panel is shorter than the alternative process. The finance manager finds the average time taken for the manufacture of each of 40 randomly chosen control panels. So now n is 40. Using the alternative process is 16.7. So they know that the T bar now is 16.7, right? He carries out the hypothesis testing at 10% significance level or level of significance, so alpha is equals to 0.1. Given that the finance manager concludes that there's no reason to reject null hypothesis, that means we do not reject H0. Find the possible values of population variance, which is sigma square, used in calculating the test statistic. So for this one, they already give you a hint. You need to find what is your test statistic and see whether it lies in the critical region or not. So if the test statistic lies in critical region, we will reject H0, right? If test statistic does not lie in critical region, we do not reject H0. So based on this question, we are doing this, right? We do not reject H0. That means the z-test does not lie in the critical region. So let's do this question. So we need to find our test statistics, and also we need to compare it with the critical region. So we need to make sure that the z-test does not lie in the critical region. Okay, so now let's write out the hypothesis testing again. So we are testing H0 of mu equals to 17 against H1 mu lesser than 17, because in this case here, they want to test whether average time taken for the manufacture of a control panel is shorter. So we are testing whether it's shorter, so it's mu lesser than 17. Okay, with that, we are given n equals to 40, t bar equals to 16.7, alpha equals to 0.1, and we are asked to find what is sigma, or basically sigma square, because it's variance. Okay, we do not have this, right? So whenever you do not have sigma, t bar, n, or mu, okay, for the hypothesis testing, it means that you need to compare your z-test versus the critical region. If it is, you have all these, okay, for your hypothesis testing, then you will do the p-value method, because this is more straightforward. All right. Okay, so as what we have talked about just now, to have no reason to reject H0 at 10% significance level, the test statistic must lie outside the critical region, right? So because we are doing a one-tail test and it is a lesser than, so this is 0.1. So if I have a normal distribution with mean 0 and a standard deviation of 1, okay, then use your inverse norm. You'll find that this value here is negative 1.28155. Okay, so in order for us to not reject H0, the z-test mustn't lie within this range. Okay, that means the z cannot be lesser than negative 1.28155. So in other words, the z-test or the test statistic must be greater than negative 1.28155. And how do you find z-test? Well, remember the formula. You'll take t bar, which is 16.7, minus mu, which is 17, over sigma over square root n. And we know that n is 40, so it's sigma over square root 40. Okay, so solving for it, you'll get sigma is greater than 1.4805. Okay, then because they did not ask for standard deviation, they asked for range of population variance, so we need to square it. So therefore, sigma square is greater than 2.19.
If you like this video, do like and subscribe. For more math resources, visit mathandsg.com.